In this video we will learn about lists. They allow us to store and work with a sequence of objects. And to create a list we use these squared brackets. In our example we will have a list of fruits. And we will represent these fruits as strings. So our first element will be an apple. And then our second element, which we separate with a comma, will be a mango. Then again comma, and now a blueberry. And finally a peach. So now we can print this list. And so now we have the strings apple, mango, blueberry and peach contained in one list. When creating a list, we're not restricted to a certain data type. So in this example here, our first element is another list. Then we have some integers, and then here a dictionary. So our elements can be any kind of object. And since in Python everything's an object, also everything can be part of a list. If we want to add new elements to our list, we can use append. So we write fruits, our list, and then dot append, and then we pass to it a new element. So in our case, we will be adding a banana. And we can see that the banana will be appended at the end of our list. If we want to add multiple elements to the end of our list, we can use, instead of append, the method extend. And then to this method we don't pass a single element, but a list. So our list here will contain banana, and then we can choose another fruit, let's say a grape, close the square brackets, and now we have extended our list by 2 new elements. If we want to add a new element at a specific location, we can use insert. So we type fruits.insert, and then to that we pass also again our element. Let's say we want to add a kiwi, and then in addition to our element we pass the position at which the new element should be inserted. So here we will choose 1. And now it is important to know how lists are indexed, because the index 1 will not refer to our first element, but to the second element. So the indexing for lists and all Python collections starts at 0. So apple has the index 0, mango 1, then 2 and 3. So if we now insert kiwi at position 1, it will be placed after the apple, so in the former position of mango. So at index not 0 but 1. Okay, so much for adding elements. Now we'll come to removing elements. And again we'll start with a method that will remove the element from the end of our list. And this method is called pop. So we write fruits.pop, and when we run it we see that the peach is gone. So it was popped from the list. When we pop an element, the element is not actually lost, but it is returned by the pop method. So we can catch it with some variable, let's say we call that popped. So now the popped element is assigned to our popped variable, and we can print it after our list. So now we have here a peach. And so by utilizing this pop and the append method, we can actually treat our list like a stack. So first we add an element at the top, and then we can pop that element. Unlike a stack, lists also allow us to pop elements at a specific index. So we can pass some index, let's say 0, and then not the last element, so the peach, but the element with that index, so in our case apple, will be popped. So now mango, blueberry, peach are intact, and the apple was removed. If we're unsure which element corresponds to which index, we can also use the remove function. So we type fruits.remove, and then we don't pass an index, but instead the actual element that we want to remove. So we can pass the string mango, and then the mango will be removed from our list. Okay, so we can add and remove elements from our list. But how can we access the elements? For that we can use indexing. So let's say we're interested in the first element. We already learned that the first element corresponds to the index 0. So let's create the variable element. And now to take the first element from the list, we write our list, then squared brackets, and inside the index corresponding to the element we want. So in our case 0 for apple. Then we can print our element. And there we have our apple. Same works if we try the index 1, that gives us the mango, 2 for blueberry, and 3 for peach. Things get interesting when we use negative numbers. So if we try -1, that will also give us peach. If we try -2, that gives us blueberry, -3 gives us mango, and -4 gives us apple. And you might have noticed that we're getting the elements in a reversed order. And so -1 always gives us the last element in our list, which can be very useful in case we don't know how long our list is. Regarding the length of our list, that is something that can be easily checked by typing len, so standing for length, and then our list. But this will give us actually an error because our list has 4 elements, but since the indices start at 0, our highest index is 3. So what we do is we subtract 1, and then we would get the last element. But using negative indices is of course more convenient. So again, we can think index 0 corresponds to the first element here, and then if we go -1 to the left, we're starting again at the end. So -1 is the end, -2 here, and then so on. If we want to access not a single but multiple elements of our list, we can use slicing. And to better illustrate this slicing, we'll use a list of numbers. And we can easily create a list of numbers using the range operator and passing that to the list constructor. So let's pass 20 to range, and then we can print that. And now we have a list containing the integers 0 up to but not including 20. So now if we want to slice our list, we again use the square brackets, and then we can define where our slice should start and where it should end. So we can slice from 0 up until, but again, not including the 10th index. And start and end are separated by a colon, and now we can print our slice. And we can see we're going from index 0 up until, but not including the 10th index. And to make this maybe a little bit less confusing, we can change our range starting from 20 to 40 so that we don't confuse values and indices. And so now again, 20 corresponds to index 0. And then here's our 9th index, which is included but not the 10th index. In addition to start and end, we can also write a step size. So we add another colon, and then let's choose a step size of 2. So now we would expect 20, then not 21, again 22, then 24, and so on. And that's what we get. We can again make things a little bit more interesting by switching to negative indices. So here with a positive step size, we were stepping from the start to the right until the end. And if we now choose a negative step size, then we would be stepping to the left. And so since from 20 on, there are no elements to the left, this slice will actually return us an empty list. So to actually get values, we have to switch the start and stop. So now we're going from the 10th index, which is here at 30, to the left with a step size of 2. So 30 is included, as you can see here, then 28, 26, 24, 22, but interestingly not 0, which makes sense because when it was swapped, the 10th index was also not included. So in this case, the 0th index is also not included. For the final method of accessing the elements, we'll go back to our fruits. And in this method, we'll use for loops. So we write for every fruit in our list of fruits, then a colon, and then the next line, we now get access to the respective fruits. So let's say we just print them. And then as we're iterating through the list of fruits, every fruit is printed. If we also want the indices of the list elements, we can use the enumerate function. So we wrap that around our list, and then this will give us not just the fruits, but also the index. So we can print first index, then fruit, and so now we have both. Okay, so we can access the elements of a list by either indexing with a single indice, or by slicing, or with these for loops. But how do we modify the elements of a list? And so to do that, we just index our element that we want to change. So let's say we want to overwrite our apple, then we index our list at index 0, and then assign to that a new value. Let's say blackberry. And let's print first our list before the change, and then after the change. And you can see that apple was overwritten to blackberry. This does not just work for single indices, but it also works for slices. So if we slice from 0 to 2, which would include the apple and the mango, then we can overwrite that slice with a new list containing apple and maybe melon. So now instead of apple and mango, we have blackberry and melon. A more interesting way of modifying the elements of a list is applying a function to it. And for that, we're switching again to our numbers. So let's create again a list of numbers between 10 and 20. And now we have again different options. For our first options, we'll change the elements in place. So we're modifying the actual list and not creating a new list. And this will again be done with a for loop. And we will also make use of enumerate. So first we'll get the index, then the list element from enumerate of nums. And so this will give us access to the indices one by one, which we'll use to access our elements. So we write the index in our square brackets, and then we'll use the original value to now overwrite that value. So the function we're here applying to our list will just be adding +2. So writing number +2. And so that's the old value, and this +2 is now our new value. So let's print our list. And we see we added +2 to every element. A more convenient way of applying functions to a list are list comprehensions. And list comprehensions will create a new list. So let's name that list nums plus 2. And because we have a new list, we'll write square brackets. And then inside these square brackets, we're defining what kind of function we're applying to every element. So in our case, the function was number plus 2. And this should be applied for every number in our nums list. So essentially, this is the head of our for loop. And then this is what will be done to the respective elements. And the result of applying the function to all the elements will then be stored in this new list. So we can print that, and we can see that nothing changes. Okay, let's recap. To add elements, we can use append. For single elements that we want to put at the end of our list, we can use extend if we want to add multiple elements at the end of our list. And we can use insert when we want to insert elements at a specific index. To remove elements, we can use pop, which pops the elements from the end of our list, or we can use pop with a specific value that will remove the elements from a specific index. To access the elements of a list, we simply write the list, then square brackets, and then the index of the element we're interested in, starting with 0. We can also use slicing, and the syntax for that is start, stop, and if we want, also a step size. If we use negative indices, that will give us the elements starting from the end of the list. And this is often easier than if we had to check the length of the list manually, which can be done with len. The final option of accessing elements was with a for loop. So for fruit, in fruits, and then we could print our fruit. We also have the option to add enumerate, which in addition would give us the index for every element. And then finally, modifying values was as easy as indexing them and then overriding them with a new value. And then finally, if we wanted to apply a function to our list, we can simply use list comprehension, which in this example we can read as we're concatenating the string choose to our fruit for every fruit in our fruits list.